In this question, we're told that the ratio of the number of boys to the number of girls in a school is 4 to 5. We're told that there are 95 girls in the school, and we need to work out the total number of students in the school. Now we can use the ratio as a fraction to help us do this. If we have a ratio of 4 to 5, we have a total of 4 plus 5 equals 9 parts, which means that when we convert our ratio into a fraction, we'll have a denominator of 9. We're told that there are 95 girls in the school, so we can say that the girls make up 5 out of 9 of the total number of students. And so following on from that, we can say that the boys make up 4/9 of the students. Since there are 95 girls in the school, we can say that 5/9 is equal to 95. Now remember that we're asked to find the total number of students in the school. In order to do this, we need to know how many boys are in the school, so that we can add the total number of boys to the total number of girls and find the total number of students. To find the total number of boys, we need to find the value of 4/9. Since we know the value of 5/9, we can divide both sides by 5 in order to find 1/9. And so we can say that 1/9 is equal to 19. Now we said that the number of boys is given by 4/9, and so to find 4/9, we'll do 1/9 multiplied by 4, which is equal to 19 times 4, which will give us an answer of 76. So we've now found that there are 76 boys in the school. So to find the total number of students, we'll do the total number of girls plus the total number of boys, which is 95 plus 76, which will leave us with an answer of 171. And so we've found that the total number of students in the school is equal to 171, which we can write down in the answer box above. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. We get the first mark for finding 1/9, which we said was equal to 19. We get the second mark for a process of using this value in order to find the total number of boys. And finally, we get the third mark for finding that the total number of students is equal to the total number of girls plus the total number of boys, which will leave us with the final correct answer of 171 students, allowing us to achieve the full 3 marks needed in this question. In this question, we're given a diagram which represents a solid made from 7 centimetre cubes. On the centimetre grid below, we're asked to draw a plan of the solid. And so the first thing that we can do is to define what a plan means. And so a plan of a 3D shape is a 2D drawing of the 3D shape when it's looked at from above. When we take a look at the solid in the diagram from above, we can see that we have 1 square at the top, then 2 squares directly below it, and then 3 squares directly below that. And so we can draw that plan on our centimetre grid. And so this fully correct plan will allow us to get the full 2 marks needed in this question. In this question, we're asked to make t the subject of the formula y equals t/3 minus 2a. Now we can start by moving the minus 2a over to the other side. And so we'll end up with y plus 2a is equal to t/3. Now to make t the subject of the formula, we want t on its own. And so to do this, we can multiply both sides by 3. And so we'll end up with 3 brackets y plus 2a is equal to t. And so we've now made t the subject of this formula. And so putting t on the left hand side, we can say that t is equal to 3 brackets y plus 2a. Alternatively, you could expand these brackets and say that t is equal to 3y plus 6a. Either way is fine, and you'll get the correct answer regardless. Now this question is worth 2 marks. So let's take a look at where these marks are allocated. Now we get the first mark for moving the minus 2a over to the other side, and for then multiplying both sides by 3. And then we get the second and final mark for getting the correct final answer of t is equal to 3 brackets y plus 2a, allowing us to get the full marks needed in this question. In this question, we're told that Jim rounds the number x to 1 decimal place, and the result is equal to 7.2. And we need to write down the error interval for x. Now we can use the diagram to help us do this. So in our diagram, we can label the middle as 7.2. And on the end, we can have 7.1, and then we can have 7.3. In between, we'll have 7.15 and 7.25. we need to think of all of the numbers that will result in 7.2 when rounded to one decimal place. So all of the numbers in between here, so for example 7.17, when we round that to one decimal place, that will round to 7.2. Or maybe when we have 7.23, when we round 7.23 to one decimal place, we'll end up with 7.2. But then say, for example, we have 7.13. When we round that to one decimal place, we'll end up with 7.1. Or maybe we have 7.28, and when we round that to one decimal place, we end up with 7.3. So we need to find the range of values that will always round to 7.2. 7.15 is the lowest value that will round to 7.2 when rounded to one decimal place. And so any number between 7.1 and 7.15 will round down to 7.1 to one decimal place. But now we can also see on the other side that we have 7.25. Now when 7.25 round to one decimal place, 7.25 will round to 7.3. So even though 7.25 will round to 7.3 to one decimal place, 7.24 or 7.249, or all of these numbers in between 7.2 and 7.25 will all round down to 7.2 to one decimal place. So we can see that any number more than or equal to 7.15 or any number less than 7.25. And so as an inequality, we can write this as x is in between 7.15 and 7.25. It's really important that we get these signs correct. The 7.15 needs a less than or equal to sign, because 7.15 will round to 7.2 to one decimal place, whereas the 7.25 needs a less than sign, because less than 7.25 will round to 7.2, but 7.25 itself will round to 7.3. Now this question is worth 2 marks. The first mark is for getting the two values of 7.15 and 7.25. And the second mark is for getting the correct symbols, by having the less than and equal to sign in the right place and the less than sign in the right place, allowing us to get the full 2 marks needed in this question. In this question, we're told that Katie measured the length and the width of each of 10 pine cones from the same tree. She used her results to draw the scatter graph. In part A, we need to describe one improvement Katie can make to her scatter graph. Taking a look at the graph, we can see that we have all of this empty space over here. And now this is because Katie started her graph at the point 0, 0. And so we can say that one improvement that Katie can make is that she can change her axes, so that her axes don't start at the origin. Now in part B, we're told that the point representing the results for one of the pine cones is an outlier. We need to explain how the results for this pine cone differ from the results for the other pine cones. Taking another look at our graph, we can identify this point as our outlier. Now looking at the general trend of the graph, as the length increases, so does the width. And so for the outlier, we would expect its width to be a lot higher than it actually is. And so the answer to part B is that the outlier pine cone has a very short width for its length. And so these two statements in part A and part B will allow us to get the full 2 marks needed in this question. In this question, we're told that at a depth of x meters, the temperature of the water in an ocean is T degrees Celsius. At depths below 900 meters, T is inversely proportional to x. T is given by the formula T is equal to 4500 over x. In part A, we're asked to work out the difference in temperature of the water at a depth of 1200 meters and the temperature of the water at a depth of 2500 meters. Let's start with 1200. When the water is at a depth of 1200 meters, we can say that the temperature T is equal to 4500 divided by x, where x is equal to 1200. And when we put this into our calculator, we can see that T is equal to 3.75. Now let's do the same for 2500. Now when the depth of water is equal to 2500 meters, T is equal to 4500 over x, which is equal to 4500 over 2500. And so putting this into our calculator, we can see that T is equal to 1.8. Now to find the difference, we'll do 3.75 take away 1.8, leaving us with an answer of 1.95 degrees Celsius. And so we've now found that the difference in the temperature of the water at a depth of 1200 meters and the temperature of water at a depth of 2500 meters is equal to 1.95 degrees Celsius. Now in part B, we're given 4 graphs. One of the graphs could show that t is inversely proportional to x. We need to write down the letter of this graph. Now let's think about what inversely proportional means. As a formula, inversely proportional would mean that t is equal to some constant k over x. Now this means that as t increases, x decreases, and vice versa. Now we can answer part B using elimination. Looking at graphs A and graph C, we can see that as t increases, x also increases. So automatically we can see that graphs A and graph C do not show inverse proportionality. Now we can look at graph B and graph D. So in graph B, we can see that as t decreases, x increases, and in graph D, we can see the same. So now we need to figure out which of these two graphs will show that t is inversely proportional to x. Looking at graph B, we can see that graph B is a straight line graph. We know that the general equation for a straight line graph is y equals mx plus c. But the general equation for inverse proportionality would be y is equal to 1 over x. Since graph B is a straight line graph and definitely has an equation in the form y equals mx plus c, we can see that graph B does not show that t is inversely proportional to x. And so we're left with a final answer of graph D. Now this question is worth 4 marks in total, so let's take a look at where these marks are allocated. In part A, we get the first mark for finding the temperature when the water has a depth of 1,200 meters. We get the second mark for finding the temperature when the water has a depth of 2,500 meters. And we get the third mark in part A for getting a correct difference of 1.95 degrees Celsius. And in part B, we get the 1 mark for getting the correct answer of D, allowing us to get the full 4 marks needed in this question. In this question, we're given a right-angled triangle with side lengths of x and y. We're told that 4 of these triangles are joined together to enclose a square ABCD, as shown below. Now we need to show that the area of square ABCD is equal to x squared plus y squared. Now let's start by labelling x and y on our diagram. So now looking at the grey triangles, we've labelled the long lengths as y and the short lengths as x. To find the area of square ABCD, we want to find the length of the base and the height, so that we can work out the area. So let's highlight what we're looking for. So now how do we go about finding the length of the base and the height? Well, since we're given the right-angled triangle, we can find the hypotenuse. And so taking a look at our diagram, the hypotenuse of the right-angled triangle is equal to the base and the height. Now we know that Pythagoras' theorem states that a squared plus b squared is equal to c squared, where c is the hypotenuse of a right-angled triangle. Now to find the base, we can say that the base squared is equal to x squared plus y squared, and so the base is equal to the square root of x squared plus y squared. Now we have the second triangle where we can do the same thing to find the height. We can say that the height squared is equal to x squared plus y squared, and therefore the height is equal to the square root of x squared plus y squared. Now to find the area of square ABCD, we do the base multiplied by the height. And so we have the square root of x squared plus y squared multiplied by the square root of x squared plus y squared. And so this will leave us with an answer of x squared plus y squared. And so we can say that area is equal to x squared plus y squared. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. We get the first mark for using Pythagoras in order to find the length of the base and the length of the height. Now we get the second mark for a process to find the area by doing the base multiplied by the height, and so we did square root of x squared plus y squared multiplied by the square root of x squared plus y squared. And the third and final mark is for getting the correct answer that the area of square ABCD is equal to x squared plus y squared, allowing us to get the full 3 marks needed in this question. In this question, we're given a diagram which shows an oil tank in the shape of a prism. The cross-section of the prism is a trapezium. We're told that the tank is empty. Oil then flows into the tank. After 1 minute, there are 300 litres of oil in the tank. We need to assume that the oil continues to flow into the tank at this rate. In part A, we need to work out how many more minutes it takes for the tank to be 85% full of oil. And we're also given a useful conversion, and we're told that 1 metre cubed is the same as 1000 litres. To solve this problem, the first thing that we can do is to find the volume of the prism. Now the volume of a prism is given by the area of its cross-section multiplied by its length. And so in this situation, the volume of this prism will be the area of the trapezium multiplied by 2.5. Now the area of the trapezium is given by the formula a plus b over 2 multiplied by the height. Now the 3 metre length we'll call A, the 1.4 metre length we'll call B, and the height h can be the 2.4 metre length. So the area of the trapezium will be equal to 3 plus 1.4 all over 2 multiplied by 2.4. And then to find the volume, we multiply this whole thing by 2.5. And so when we put this whole thing into our calculator, we can see that the volume of the prism is equal to 13.2 meters cubed. Now since we're told that after 1 minute there are 300 litres of oil in the tank, it will be useful to convert the volume of the prism into litres. Since 1 meter cubed is equal to 1000 litres, we can find the volume of the prism in litres by doing 13.2 multiplied by 1000. And so we can say that the volume of the prism is equal to 13,200 litres. Since we're asked to find how many more minutes it takes for the tank to be 85% full of oil, the next thing that we can do is to find 85% of the total volume of the prism. So to do this, we can do 0.85 multiplied by 13,200, which is equal to 11,220 litres. Now the next thing that we can do is to find the total time taken for the tank to be 85% full of oil. So if we're told that it takes 1 minute to fill 300 litres, we want to know how long it will take to fill 11,220 litres. Now to get from 300 to 11,220, we multiply by 37.4. Now doing the same thing to the other side, 1 minute multiplied by 37.4 is equal to 37.4 minutes. But now this isn't our final answer. We're asked to find out how many more minutes it takes for the tank to be 85% full of oil. The total time it will take to be 85% full will be 37.4 minutes, but we had been told before that after 1 minute there had already been 300 litres of oil. And so to find how many more minutes it takes for the tank to be 85% full of oil, we need to find the difference between these values. And so we'll do 37.4 take away 1, which is equal to 36.4 minutes, which we can write down in our answer box below. Now in part B, we're told that the assumption about the rate of the flow of oil could be wrong, and we need to explain how this could affect our answer to part A. Now the rate of the flow of oil describes the amount of oil being filled in the tank per unit time. Now if the rate of the flow of oil was faster, that means it would take less time for the tank to fill up. But if the rate of the flow of oil was slower, that means it would take more time for the tank to fill up, and we can write this down below. Now this question is worth 6 marks in total, so let's take a look at where these marks are allocated. Now part A is worth 5 marks. We get the first mark in part A for a process to find the area of the trapezium, and so we did 3 plus 1.4 all divided by 2 multiplied by 2.4. And then we get the second mark for multiplying this value by 2.5 in order to find the total volume of the prism. The third mark in part A is for finding 85% of the total volume. We then get our 4th mark for finding the total time taken for the tank to contain 11,220 litres, and we found that this value was 37.4 minutes. And finally, the 5th mark is for finding the difference between 37.4 and 1, and for therefore getting a final answer that it takes 36.4 more minutes for the tank to be 85% full of oil. Now in part B, we get 1 mark for a correct explanation by saying that if the average rate was slower, it would take more time, and if the average rate was faster, it would take less time. And so we've now achieved the full 6 marks needed in this question. In this question, we're told that Ibra bought a house for £145,000. The value of the house depreciated by 4% in the first year, and the value of the house depreciated by 2.5% in the second year. Now Ibra says that 4 plus 2.5 is equal to 6.5, and so in 2 years, the total value of his house would depreciate by 6.5%. And in part A, we need to find out if Ibra is correct. And so to do this, we can work out the actual percentage by which the value of the house will decrease in the 2 years. Now let's write these percentages as multipliers. When we depreciate by 4%, we want to multiply by 0.96. And when we depreciate by 2.5%, we want to multiply by 0.975. So to find out the total percentage by which the value of the house depreciated after 2 years, we'll do 0.96 multiplied by 0.975. And when we put this into our calculator, we'll get an answer of 0.064. Now writing this as a percentage, 0.064 is equal to 6.4%. So we can see that the value of the house actually depreciates by 6.4% in 2 years, and not 6.5% as Ibra says. So let's write that down below. Isn't that 0.96 multiplied by 0.975 is equal to 0.936. 1 take away 0.936 is equal to 0.064. 0.064 means that the value of the house depreciates by 6.4% over the 2 years. 6.4% is not equal to 6.5%, and therefore we can say that Ibra is incorrect. In part B, we're told that the value of Ibra's house increases by X% in the 3rd year. At the end of the 3rd year, the value of Ibra's house is £140,000. We need to work out the value of X, giving our answer correct to 3 significant figures. Now since we have a different multiplier in each year, we can calculate each year separately. So we'll start with year 1. We have a starting value of £145,000. Now in year 1, this value depreciates by 4%. So £145,000 multiplied by 0.96 is equal to £139,200. Now let's move on to year 2. So in year 2, we have a starting value of £139,200. In year 2, we depreciate by a value of 2.5%, so we multiply by 0.975, and we get an answer of £135,720. Now let's move on to year 3. So we have a starting value of £135,720. Now this increases by X%. Now since we have an increase, we'll multiply by 1 point something. And that something is equal to X as a multiplier. Now since X is a percentage, X as a multiplier is the same as X divided by 100. And so we'll be multiplying by 1 plus X over 100 as our multiplier. And we get a final value of £140,000. So to find 1 plus X over 100, we can divide both sides by £135,720. And so doing 140,000 divided by 135,720, we can see that 1 plus X over 100 is equal to 1.0315355514 ... So to find x over 100, we can take 1 away from both sides, and so we can see that x over 100 is equal to 0.031535514 ... Now to find the value of x, we can multiply both sides by 100. So we can say that x is equal to 3.15%, correct to 3 significant figures. And so we can write this down in our answer box. Now this question is worth 5 marks, so let's take a look at where these marks are allocated. Now in part A, we get 1 mark for saying that Ibra is not correct. And we get the second mark for a full explanation, saying that the value of the house actually depreciates by 6.4%, not 6.5%. Now in part B, we get 1 mark for finding the value of the house after 2 years, which we found was £135,720. Now the second mark is for using this value to find the multiplier by which the value of the house is multiplied to give £140,000 as a final answer. And now the third and final mark in part B is for rearranging to find that x is equal to 3.15%. And so we've now achieved the full 5 marks needed in this question. In this question, we're told that the surface gravity of a planet can be worked out using the formula G is equal to 6.67 times 10 to the minus 11 multiplied by m, all divided by r squared, where m kilograms is the mass of the planet and r meters is the radius of the planet. So for Earth and Jupiter, we're given the values of m and r below. We need to work out the ratio of the surface gravity on Earth to the surface gravity on Jupiter, writing our answer in the form 1 to n. And for those of you who go on to study A-level physics, you'll come across this formula again, and 6.67 times 10 to the minus 11 is actually equal to something called the gravitational constant. But coming back to this question, let's start by finding the surface gravity on Earth. So the surface gravity G is equal to 6.67 times 10 to the minus 11 multiplied by the mass, and we can see that the mass of Earth is 5.98 times 10 to the 24 all over the radius squared, and we know that the radius is 6.378 times 10 to the power of 6. And a common mistake is forgetting to square the denominator, so make sure we have that squared in our formula. And so putting these values into our calculator, we can see that the surface gravity on Earth is equal to 9.80523457.8 ... And we're not going to round our answer just yet, because we haven't finished working out the full question. Now let's move on to find the surface gravity on Jupiter. So doing the same thing that we did before, G is equal to 6.67 times 10 to the minus 11 multiplied by the mass, which we can see is 1.90 times 10 to the power of 27 all over r squared, and we can see that r is equal to 7.149 times 10 to the power of 7. And again, make sure you remember to square the denominator. So we'll get an answer that the surface gravity on Jupiter is equal to 24.79641183 ... Now we want to work out the ratio of the surface gravity on Earth to the surface gravity of Jupiter. And so based on our answers, we can see that the ratio of the surface gravity on Earth to the surface gravity on Jupiter is 9.80523457.8 to 24.79641183 ... Now we're asked to give this in the form 1 to n, and we don't know what n is. Now to get from 9.805 ... all the way to 1, we need to divide by the very long value of 9.80523457.8, and do the same thing on both sides. We can see that n is equal to 2.52889532. And so now that we've reached our final answer, we can round to an appropriate number of significant figures. and so rounding to 3 significant figures, we can say that the ratio of the surface gravity of Earth to the surface gravity of Jupiter is equal to 1 to 2.53, correct to 3 significant figures. And we can write down this value in our answer box. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. We get the first mark for substituting in the correct values to find the surface gravity of Earth and the surface gravity of Jupiter. Now the second mark is for a process to find n. We needed to write our answer in the form 1 to n, so we divided both sides by 9.805, ... And the third and final mark is for getting a correct final answer that the ratio of the surface gravity of Earth to the surface gravity of Jupiter is 1 to 2.53, allowing us to get the third and final mark needed in this question. In this question, we're asked to solve the simultaneous equations 2x minus 4y equals 19 and 3x plus 5y equals 1. Let's call this equation equation 1 and this equation equation 2. Now let's start with equation 1. We have 2x minus 4y is equal to 19. So we can solve for x. We can say that 2x is equal to 19 plus 4y because we added 4y to each side. And now we can divide both sides by 2 to find x. And so x is equal to 19 plus 4y all divided by 2. Now we can substitute this value for x into equation 2. In equation 2, we have 3x plus 5y is equal to 1. We found that x is equal to 19 plus 4y all divided by 2. And so we can substitute this value in. 3x is the same as 3 multiplied by 19 plus 4y over 2 plus 5y equals 1. Let's expand these brackets. 3 multiplied by 19 plus 4y all divided by 2 is the same as 57 plus 12y over 2 plus 5y equals 1. Now we can multiply each term by 2, and so we can say that 57 plus 12y plus 10y is equal to 2. Now we can simplify this. Moving the 57 over to the other side, we can say that 22y is equal to 2 take away 57, which is minus 55. And so y, dividing both sides by 22, is equal to minus 2.5. And now that we've found the value of y, we can substitute this into either equation to find the value of x. So let's substitute y into equation 1. We have 2x minus 4y equals 19. Now that's the same as 2x minus 4 times minus 2.5 equals 19. And so remember that a negative multiplied by a negative would give you a positive. And so we can say that 2x plus 10 is equal to 19. Now moving the plus 10 over to the other side, we can say that 2x is equal to 19 take away 10, which is equal to 9. And so x, dividing both sides by 2, is equal to 4.5. And so we've now found the correct values for x and y, which we can write down in the space provided. Now this question is worth 4 marks, so let's take a look at where these marks are allocated. We get 1 mark for a process to use either one of the equations to find x in terms of y. And so we said that x is equal to 19 plus 4y, all divided by 2. We get the second mark for substituting this value in to the other equation in order to find y, which we said was equal to minus 2.5. The third mark was for substituting the value of y into either of the 2 equations to find the value of x. And the fourth and final mark is for getting the 2 correct values, that x is equal to 4.5 and y is equal to minus 2.5, allowing us to get the full 4 marks needed in this question. In this question, we're told that Zara mixes 150 grams of metal A and 150 grams of metal B to make 300 grams of an alloy. Metal A has a density of 19.3 grams per centimeter cubed. Metal B has a density of 8.9 grams per centimeter cubed. We need to work out the density of the alloy. Now to find the density of the alloy, We can first identify that density is equal to mass divided by volume. We already know that the total mass of the alloy is 300 grams, so we need to work on finding the total volume of the alloy. And to do this, we can find the volume of metal A and the volume of metal B. Let's start with the volume of metal A. We're told that the density of A is equal to 19.3 grams per centimeter cubed. So we can say that in 19.3 grams, there is 1 centimeter cubed of metal A. Now we have 150 grams of metal A. So we need to find the volume that we'll have in 150 grams. And so to get from 19.3 grams to 150 grams, we can multiply by 150 divided by 19.3. And we have to do the same to both sides. And so we can say that in 150 grams of metal A, we have a volume of 7.772020725 centimeters cubed. Now let's move on to finding the volume of B. So we're going to do the exact same thing again. Metal B has a density of 8.9 grams per centimeter cubed, which means that in 8.9 grams of metal B, we have 1 centimeter cubed. We want to find the volume of 150 grams, and so to get from 8.9 to 150, we multiply by 150 divided by 8.9, and doing the same to both sides, we can see that 150 grams of metal B will give us 16.85393258 centimeters cubed. Now that we've found the volume of A and the volume of B, we can say that the total volume of the alloy is equal to 7.77 plus 16.85, which will give us an answer of 24.625953331 centimeters cubed. Now to find the density of the alloy, we'll do the total mass divided by the total volume. We know that the total mass is equal to 300 grams, and the total volume is equal to 24.62595 ... Putting this value into our calculator, we'll find that the density of the alloy is equal to 12.2 grams per centimeter cubed, correct to 3 significant figures, which we can write down in our answer box. Now this question is worth 4 marks, so let's take a look at where these marks are allocated. We get 1 mark for a process to find the volume of A, and then to find the volume of B. We get the second mark for a process to find the total volume of the alloy by adding the volume of A and the volume of B together. We get the third mark for a process to find the density of the alloy by doing the total mass divided by the total volume. And then we get the fourth and final mark for getting a correct final answer that the density of the alloy is equal to 12.2 grams per centimeter cubed, allowing us to get the full 4 marks needed in this question. In this question, we're given a triangle, and we're told to enlarge the triangle by a scale factor of -1.5 at a centre of 0,2. Now let's first start by identifying the point 0,2, which we can locate to be right over here, which we marked in purple. Now to enlarge the triangle by a scale factor of -1.5, we need to make it 1.5 times bigger than it currently is, and the minus suggests that we're changing direction. So let's take a look at how we do this. We'll call this point A, this point B, and this point C. Since we're enlarging this triangle about the point 0,2, we need to make sure that all of our points relate to the coordinate 0,2. And so we'll call the point 0,2 x, as marked in our diagram. Now to get from x to A, we can see that we move 4 spaces to the right. Now to enlarge this by a scale factor of -1.5, 4 multiplied by 1.5 is equal to 6, but the minus suggests that we need to do this in the opposite direction. So instead of moving 4 spaces to the right, we need to move 4 times 1.5 spaces to the left, which means we're moving 6 spaces to the left. And so let's show that in another colour. So let's mark this point as A dash. Now let's look at point B. To get from the centre X to point B, we go 2 spaces up and then 2 spaces to the right. 2 multiplied by 1.5 is equal to 3. We know that we're going to be moving 3 spaces. And again, the minus means we need to change direction. So to get to point B, we did 2 spaces up and 2 spaces to the right. And so to get to the new point B, we'll do 2 times 1.5 spaces down and 2 times 1.5 spaces to the left, which means 3 spaces down and 3 spaces to the left. And we'll mark this point as B dash. Now finally, let's move on to point C. To get from centre X to point C, we'll go 2 spaces up, and then we'll go 4 spaces to the right. Now doing the same thing that we've been doing for points A and for points B, we're going to multiply by 1.5 and move in the opposite direction. So 2 spaces up and 4 spaces to the right will change to 2 times 1.5 spaces down and 4 times 1.5 spaces to the left, which means 3 spaces down and 6 spaces to the left. And so we'll mark this point as C dash. Now that we have our 3 points in our new triangle, let's join them together. And now let's get rid of all the other lines which might make everything a bit more confusing. And so we've now successfully enlarged this triangle by a scale factor of -1.5 about the centre 0, 2. And now we get the 2 marks in this question for getting all the correct points in our new triangle and for getting the correct size, allowing us to get the full marks needed in this question. In this question, we're given a table which provides information about the speeds in kilometers per hour of 81 cars. Now in the table, we're given the speed and we're given the frequency. And in part A, we need to draw a histogram for the information on the table. So with histograms, we often have bars of unequal width, which we can see in the different groups. We have 90 to 100, which have a width of 10, but 100 to 105 has a width of 5, or 120 to 140 has a width of 20. So with a histogram, we take this into account by using something called a frequency density. And the frequency density is given by the frequency divided by the class width. Now we can draw a third column on our table in order to find the frequency density for each group, because we'll be using the frequency density when we draw a histogram. So we said that frequency density is equal to the frequency divided by the class width. So for the first row, we have a frequency of 13 and a class width of 100 take away 90, which is equal to 10. And so the frequency density is equal to 13 divided by 10, which is 1.3. For the second row, we have a frequency of 16 and a class width of 5, and so our frequency density is 16 divided by 5, which is 3.2. For our third row, we have a frequency of 18 and a class width of 5, and so our frequency density is 18 divided by 5, which is equal to 3.6. For the fourth row, we have a frequency of 22 and a class width of 10, and so our frequency density is 22 divided by 10, which is 2.2. And finally, in our last row, we have a frequency of 12 and a class width of 20, and so our frequency density is 12 divided by 20, which is equal to 0.6. Now we can begin to plot our histogram. And in our histogram, we'll have the speed on the x-axis and the frequency density on the y-axis. So let's begin to draw a suitable scale on our axes. We'll start with the speed. And on our x-axis, we'll start with 90 and we'll go up in intervals of 10. Always remember to label our axes, and so we'll label the x-axis as speed, and in brackets we'll write the units of kilometers per hour. Now let's draw a suitable scale on our y-axis, and so we'll label our y-axis as frequency density. We can begin to draw our bars. So between 90 and 100, we have a frequency density of 1.3. We can now draw a line at 1.3 between 90 and 100. We'll draw the vertical line downwards to mark the end of the box. Now moving on to 100 to 105, and we have a frequency density of 3.2. 105 is located over here, and we're going to go vertically upwards until we get a frequency density of 3.2. And then we can draw a line across to 100, and then go down like this. So between 100 and 105, we have a frequency density of 3.2. Now between 105 and 110, we have a frequency density of 3.6. So let's do the same thing. Now between 110 and 120, we have a frequency density of 2.2. Now finding 2.2 on our y-axis, we can draw a cross from 110 to 120. and between 120 and 140, we have a frequency density of 0.6. And again, finding 0.6 on our y-axis, we can draw a cross until we get to 140. And so we've now drawn a fully correct histogram with the information given to us in the table. Now in part B, we're asked to find an estimate for the median. So to find the median, let's first start by finding the total frequency. We have a screenshot of our table above, and so we can see that the first box has a frequency of 13, the second box has a frequency of 16, the third has a frequency of 18, the fourth box has a frequency of 22, and finally the fifth box has a frequency of 12. Now to find the total frequency, we'll do 13 plus 16 plus 18 plus 22 plus 12, which is equal to 81. Now we can find the median position. The median position is found at the halfway point of the data, and so our halfway point will be 81 divided by 2, which is equal to 40.5. And so we can say that our median is found at the 40.5th value in our data. Now to find an estimate for the median using our histogram, we need to find out which bar the median value is found in. Looking at the first bar, we have a frequency of 13. If the median position is found at a frequency of 40.5, 13 is definitely too small. And so the median position will not be found in the first box. Now let's look at the second box. In the second box, our total cumulative frequency will be 13 plus 16, which is equal to 29. 29 is still less than 40.5, so our median position won't be found here. Now let's look at the third box. We can do 13 plus 16 plus 18, and see that we'll have a total cumulative frequency of 47 in our third box. We can see that the third box starts at a frequency of 29 and ends at a frequency of 47. So we know that the 40.5th value will lie in between 29 and 47. And so the median position will be found in the third box. And so to find the 40.5th value, well, we can see that the first 13 are used up in the first box, so we can take away 13. And then the next 16 are used up in the next box, and so we can take away 16 now. And so 40.5 take away 13 take away 16 is equal to 11.5. And so we have a remaining frequency of 11.5, which means that we're looking for the 11.5th value in the third box. We know that the third box has a frequency density of 3.6. Like we said before, the frequency density is equal to frequency divided by the class width. And since we want to find class width this time, the class width is equal to the frequency divided by the frequency density. When the frequency is equal to 11.5, we can say that the class width is equal to 11.5 divided by 3.6, which is equal to 3.19444 ... Now remember that this class width only counts for the third box. Now before the third box started, we already had a speed of 105. And so to find the median, we'll do 105 plus 3.1944 ... which is equal to 108.1944 ... And so rounding our answer to three significant figures, we can see that we have a median of 108 kilometers per hour. Now this question is worth 5 marks, so let's take a look at where these marks are allocated. In part A, we get 1 mark for finding the correct frequency densities of the values in our table. We get the second mark for all of the bars in our histogram having the correct proportions. And we get the third mark in part A for having a fully correct histogram with the axes scaled and labelled. Now there are 2 marks in part B, and we get the first mark for finding that the median is in the 40.5th position and that the class width at this point in the third box is equal to 3.19444. And then we get the second mark in part B for getting the correct answer that the median is equal to 108 kilometers per hour. And now we've achieved the full 5 marks needed in this question. In this question, we're asked to show that a over b plus 1 minus a over b plus 1 all squared can be written as ab over b plus 1 all squared. Now when we add or subtract fractions, we need to make sure that the fractions have a common denominator. Now b plus 1 and b plus 1 squared are not the same, but we can make these two fractions have a common denominator. We can leave the second fraction as a over b plus 1 all squared, and for the first fraction, we'll multiply both the numerator and the denominator by b plus 1, so that we have a denominator of b plus 1 all squared. So multiplying the numerator and the denominator by b plus 1, we can say that a over b plus 1 is equal to a multiplied by b plus 1 over b plus 1 all squared. And we can expand the brackets in the numerator, and so ab plus a over b plus 1 squared. Now we can say that ab plus a over b plus 1 squared take away a over b plus 1 squared. And to find the answer for this, well, since we have a common denominator, we can write this in a simpler way. And so we can say that ab plus a minus a over b plus 1 squared. Now plus a and minus a will cancel out, and we're left with ab over b plus 1 all squared. And so we've now shown that a over b plus 1 minus a over b plus 1 all squared can be written as ab over b plus 1 all squared. Now this question is worth 2 marks, so let's take a look at where these marks are allocated. We get the first mark for converting the first fraction, a over b plus 1, and making it have a denominator of b plus 1 all squared. And we get the second mark for then subtracting these two fractions in order to get a final answer of ab over b plus 1 all squared, allowing us to get the full 2 marks needed in this question. In this question, we're given a diagram which shows a sector of a circle of radius 4 centimeters. We need to work out the length of arc ABC, giving our answer correct to 3 significant figures. We know that the formula for arc length is given by theta over 360 multiplied by 2 pi r. Now an easy mistake here would be to assume that theta is equal to 100, but actually theta is this angle inside the sector. And so given that angles around a point add up to 360 degrees, we can find theta by doing 360 take away 100, and so theta is equal to 260 degrees. So now to find arc length, we'll do 260 over 360 multiplied by 2 times pi times a radius of 4 centimeters. Now plugging this entire expression into our calculator, we'll get an answer that the arc length is equal to 18.15142.422 centimeters. We're asked to give our answer correct to 3 significant figures, and so we can say that the arc length of this sector is equal to 18.2 centimeters. Now this question is worth 2 marks. The first mark is for recognising that theta is equal to 260 degrees, and for using this value in our formula for the arc length. And the second mark is for getting a correct final answer that the arc length is equal to 18.2 centimeters to 3 significant figures, allowing us to get the full 2 marks needed in this question. In this question, we're told that the product of 2 consecutive positive integers is added to the larger of the 2 integers. And we need to prove that the result is always a square number. Now let's call these positive integers n and n plus 1. Now the second positive integer has to be n plus 1 because we're told that these 2 positive integers are consecutive, which means they're one after the other. So we now have our 2 positive integers n and n plus 1. We'll start by finding the product of these 2 consecutive positive integers. And so the product is what we get when we multiply the 2 integers together. N multiplied by n plus 1 is equal to n squared plus n. Now the product of the 2 consecutive positive integers is added to the larger of the 2 integers. Now we know that n plus 1 is larger than n. And so now we can do n squared plus n plus the larger of the 2 integers, so plus n plus 1, and we need to find the result. So n squared plus n plus 1 is equal to n squared plus 2n plus 1. We need to prove that this result is always a square number. Now n squared plus 2n plus 1 is a quadratic equation which we can simplify. And so we can say that n squared plus 2n plus 1 is equivalent to n plus 1 all squared. Now that we've found that the result is equal to n plus 1 all squared, we've proven that the result is always a square number, and it's really important to write a conclusive statement at the end to get the final mark. So we can say that n plus 1 all squared is always a square number because any number squared is going to be a square number. And so we've proven that the product of two consecutive positive integers added to the larger of the two integers is always a square number. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. We get the first mark, finding that the product of the two consecutive positive integers is equal to n multiplied by n plus 1. We get the second mark for adding this value to the larger of the two integers, and for doing n squared plus n plus plus 1 is equal to n squared plus 2n plus 1. And we get the third and final mark for realising that this is equivalent to n plus 1 all squared, and for writing a final conclusive statement that the result of the product of the two consecutive positive integers plus the larger of the two integers will always be a square number because n plus 1 all squared is a square number, allowing us to get the full 3 marks needed in this question. In this question, we're given a speed time graph for a car, and in part A, we're asked to work out an estimate for the distance the car travelled in the first 10 seconds, using 5 strips of equal width. So let's start by dividing our graph into these 5 strips. So for the first 10 seconds, we've split our graph into these 5 strips, which each have a width of 2. And so we can see that each of these strips is a trapezium. Now to find an estimate for the distance on a speed time graph, we need to find the area under the curve. And so using our 5 trapezia, we can find the area of each individual trapezium and add them together in order to find an estimate for the distance the car travelled in the first 10 seconds. Now we know that the area of a trapezium is given by the formula a plus b over 2, all multiplied by the heights. And so on the purple diagram, you can see that a and b are the 2 sides on either end, and the height is the width at the bottom. Now we can simplify things to make our calculations a little bit easier. For all of our individual trapezia, we have a height of 2, will be a plus b over 2, all multiplied by 2. And so we can simplify this by saying that the area of each trapezium is equal to a plus b, since the width of each trapezium is equal to 2. Now we can work on finding the area of each individual trapezia. We need to find the height of all of the strips. So reading from our graph, this first height is equal to 2, the next height is equal to 5, the next height is equal to 9, then we have a height of 15, and finally our last height is equal to 24. Now let's work out the area of each individual trapezium. We'll start with trapezium 1. For trapezium 1, a is equal to 0 and b is equal to 2. So the area of trapezium 1 is equal to 0 plus 2, which is equal to 2. Now moving on to trapezium 2, a is equal to 2 and b is equal to 5. And so the area of trapezium 2 is 2 plus 5, which is equal to 7. Now moving on to trapezium 3, the length a is equal to 5 and the length b is equal to 9. And so the area of trapezium 3 is 5 plus 9, which is equal to 14. For trapezium 4, a is equal to 9 and b is equal to 15. And so the area is equal to 9 plus 15, which is equal to 24. And finally trapezium 5, a is equal to 15 and b is equal to 24. And so the area is equal to 15 plus 24, which is equal to 39. So now to find the total area in the first 10 seconds, we can add all of these areas together. And so the area of the graph in the first 10 seconds is equal to 2 plus 7 plus 14 plus 24 plus 39, which is equal to 86. Now we said that the area under the graph in the first 10 seconds is an estimate for the distance that the car has travelled. And so we can say that an estimate for the distance the car travelled in the first 10 seconds is equal to 86 metres, which we can write down in our answer box below. Now in part B, we're asked if our answer to part A is an underestimate or an overestimate of the actual distance, giving a reason for our answer. Now looking back at our graph, we can see that our estimation is an overestimate because the graph is actually a curve, and when we drew our trapezia, we made the area under the graph bigger than what it actually is, which we can see in the little bits of white space, which shows that our shapes were actually slightly bigger than the area under the curve itself. and so we can write this down with an explanation below. And so we've concluded that our answer to part A is an overestimate of the actual distance because the graph is a curve and the trapezia that we drew are larger than the actual area under the curve. Now this question is worth 4 marks. So let's take a look at where these marks are allocated. Now part A is worth 3 marks, and the first mark is for starting to show that we're finding the area under the graph, and so automatically our annotations in the graph show this. And the second mark is for finding the area of each trapezium. And our third mark in part A is for adding these together to find an area of 86 and for working out that an estimate for the distance the car travelled in the first 10 seconds is equal to 86 metres. And in part B, we get the 1 mark for stating that our answer to part A is an overestimate because the graph is a curve and the trapezia are larger than the actual area under the curve. And so we've now achieved the full 4 marks needed in this question. In this question, we're asked to prove algebraically that the recurring decimal 0.318 can be written as 7/22. Now in our decimal, only the 1 and the 8 are recurring, and so 0.318 recurring can be written as 0.3181818, and on. Now we're going to say that x is equal to this value. Now what we're going to do is to say that 10x is equal to 3.181818 ... 100x is equal to 31.818181 ... and 1000x is equal to 318.181818 ... Now take a look at the values of 10x and 1000x. We can see that the numbers after the decimal points are equal. We have 0.181818 ... for 10x, and for 1000x we also have 0.181818. So let's take a look at what happens when we do 1000x take away 10x. 1000x take away 10x is equal to 318.181818 ... take away 3.181818 ... So now automatically we can see that the numbers after the decimal point, the 181818, both cancel out. And so by doing this, we've made our problem a lot simpler by getting rid of the recurring decimal. And so 318 take away 3 is equal to 315. So we've said that 1000x take away 10x is equal to 315. And so we can simplify this by saying that 990x is equal to 315. We can say that x is equal to 315 divided by 990, and so when we divide the numerator and the denominator by 45, we can see that x is equal to 7/22. Now we said that x is equal to 0.3181818, which is the recurring decimal given to us in the beginning of this question. We found that x is equal to 7/22, and therefore we can say that 0.318 recurring is equal to 7/22. Now this question is worth 2 marks, so let's take a look at where these marks are allocated. We get the first mark for finding the values of 1000x and 10x, and noticing that when we subtract these values, we get a whole integer, which doesn't contain any of the recurring values at the end. And now the second mark is for saying that 990x is equal to 315, and when we rearrange and simplify, we found that x is equal to 7/22. And so we've shown that 0.318 recurring can be written as 7/22, allowing us to get the full 2 marks needed in this question. In this question, we're told that OAB is a triangle, and P is the point on AB such that AP to PB has a ratio of 5:3. We're told that the vector OA is equal to 2A, the vector OB is equal to 2B, and the vector OP is equal to K multiplied by 3A plus 5B, where K is a scalar quantity. We need to find the value of K. Now we know the vector OA and the vector OB, and it would be useful to know the value of vector AB. And we can find this out using the vectors given to us. Now we can trace the path of vector AB using a highlighter. So we can see that the vector AB is equal to AO plus OB. Now the vector OA is equal to 2A, but the vector AO is in the opposite direction. So we can say that the vector AO is equal to minus 2A instead of 2A. And so AO plus OB is equal to minus 2A plus 2B. And so we can write down that the vector AB is equal to 2B minus 2A. Now remember, we're trying to find the value of K, and we're told that the vector OP is equal to K multiplied by 3A plus 5B. Now we can trace the path of vector OP by highlighting in a different colour. And so we can say that the vector OP is equal to OA plus AP. We found out that vector AB is equal to 2B minus 2A. And to find the vector AP, we can use the ratio given to us at the beginning of the question. If P is a point on AB such that the ratio of AP to PB is equal to 5 to 3, we can say that the line AB is made up of a total of 5 plus 3, which is equal to 8 parts. Now since AP makes up 5 parts, we can say that the line AP is 5/8 of the line AB, which we can work out below. We said vector AP is equal to 5/8 of the vector AB, which is 5/8 of 2B minus 2A. And so expanding these brackets, we can say that the vector AP is equal to 5 over 4B minus 5 over 4A. So now going back to vector OP, OP is equal to OA plus AP. The vector OA is equal to 2A plus the vector AP, so plus 5 over 4B minus 5 over 4A. And so simplifying this by collecting like terms, we can say that the vector OP is equal to 3 over 4A plus 5 over 4B. Now we can factorise this, and we can say that the vector OP is equal to 1 over 4 multiplied by 3A plus 5B. Now in the beginning of the question, we were told that the vector OP is equal to K multiplied by 3A plus 5B, where K is a scalar quantity. We've found that the vector OP is equal to a quarter multiplied by 3A plus 5B, and so we can say that K is equal to 1 over 4, which we can write down in our answer box below. Now this question is worth 4 marks, so let's take a look at where these marks are allocated. We get the first mark for finding the value of vector AB, which we said was equal to 2B minus 2A. We get the second mark for finding the value of vector AP, which we said was equal to 5 over 4B minus 5 over 4A. We get the third mark for a complete process to find the value of vector OP, which we said was equal to 3 over 4A plus 5 over 4B. And the fourth and final mark is for factorising 1 over 4 out of the vector OP, and we said that the vector OP is equal to 1 over 4 multiplied by 3A plus 5B, and so we found that the value of K is equal to 1 over 4, allowing us to get the full 4 marks needed in this question. In this question, we're told that ABC is a triangle, and D is a point on AB. We need to work out the area of triangle BCD, giving our answer correct to 3 significant figures. Now to find the area of triangle BCD, we want to use the formula A is equal to half AB sine C. And so in the case of triangle BCD, we'll say A is equal to line CD, B is equal to line CB, and C is equal to 25 degrees. And so in order to work out the area of triangle BCD, we need to find the length of line CD and line CB. Now let's highlight triangle BCD to make this a little bit clearer to see. So we can start by finding the line CD using the cosine rule. And so we can say that CD squared is equal to 4.9 squared plus 3.8 squared minus 2 times 4.9 times 3.8 times cos 80. And so putting these values into our calculator, we can see that the line CD is equal to 5.65538167 centimeters. Now that we've found line CD, we need to find line CB. We can start by finding the angle CDA using the sine rule. We can say that sine 80 over 5.6553 is equal to sine ADC over 4.9. 4.9 sine 80 is equal to 5.6553 multiplied by sine ADC. And so we can say that angle ADC is equal to sine minus 1, 4.9 sine 80 divided by 5.6553 . And so using our calculator, we can see that angle ADC is equal to 58.5688949 degrees. Now let's find angle CDB. We know that angles in a straight line add up to 180 degrees. And so angle CDB is equal to 180 take away 58.5689, which is equal to 121.431051 degrees. Now looking at triangle BCD, we know angle DCB and angle CDB, and so we can use these angles to find angle CBD, because angles in a triangle add up to 180 degrees. And so angle CBD is equal to 180 take away 25 plus 121.431, which is equal to 33.5688949 . Now we can find the length of line CB using the sine rule. We can say that sine 33.56 over 5.6553 is equal to sine 121.431 over CB. When we cross multiply, we'll find that CB sine 33.56 is equal to 5.65 multiplied by sine 121.431 . And so line CB is equal to 5.65 multiplied by sine 121.431 all divided by sine 33.568 . And so typing this into our calculator, we'll find that the line CB is equal to 8.7270900379 centimeters. And finally, we can find the area of triangle BCD using the formula A equals half AB sine C. And so we can say that the area of triangle BCD is equal to 1/2 multiplied by 5.655 multiplied by 8.727 multiplied by sine 25, which is equal to 10.42916786 centimeters squared, which is equal to 10.4 centimeters squared to 3 significant figures, which we can write in the answer box above. Now this question is worth 5 marks, so let's take a look at where these marks are allocated. We get the first mark for using the cosine rule to find the length of line CD. We get the second mark for using the sine rule to find the angle ADC. We get the third mark for using the sine rule to find the line CB. Now after having found lines CD and CB, we get the fourth mark for using the formula A equals half AB sine C to find the area of triangle BCD. And we get the fifth and final mark for a correct final answer, that the area of triangle BCD is equal to 10.4 centimeters squared, correct to 3 significant figures, allowing us to get the full 5 marks needed in this question. In this question, we're told that there are Y black socks and 5 white socks in a drawer. Joshua takes at random 2 socks from the drawer we're told that the probability that Joshua takes one white sock and one black sock is 6 out of 11. And we need to show that 3y squared minus 28y plus 60 is equal to 0. We can start by drawing a tree diagram to represent this information. So let's start with the first go. We know that there are y black socks and 5 white socks, and so the total number of socks is 5 plus y. This will be our denominator. If there are y black socks, the probability of taking a black sock on the first go is y over 5 plus y, which we've written on our tree. And then the probability of choosing a white sock would be 5 over 5 plus y, which is written on our tree diagram. Now we're told that Joshua takes 2 socks from the draw, which means our tree diagram isn't quite finished. Let's imagine that Joshua takes a black sock from the draw. Now that he has taken a sock from the draw, the number of socks from the draw decreases by 1, and so the new total number of socks will be 5 plus y, take away 1, which is the same as 4 plus y. Now if Joshua takes a black sock, the number of black socks will decrease by 1, but the number of white socks will stay the same, and so we'll have new fractions. Once Joshua has taken a black sock, the new probability of choosing a black sock again will be y take away 1, since there are y minus 1 black socks left, over 4 plus y, and the probability of taking a white sock would be 5 over a new denominator of 4 plus y. Now we can apply the same logic if he takes a white sock the first time round. If Joshua takes a white sock on his first go, we're still removing 1 sock from the draw, and so the new total number of socks will still be 5 plus y, take away 1, which will be 4 plus y. And so our denominator will still be 4 plus y. Now if he takes a white sock on the first time round, the number of black socks will be unchanged, and so the probability of taking a black sock the second time round will be y over 4 plus y, and then the probability of taking a white sock the second time round, well, since we already took a white sock the first time round, the number of white socks will decrease from 5 to 4, and so the new probability of choosing a white sock on the second go would be 4 over 4 plus y. Now that we have our fully completed tree diagram, we can begin to solve this problem. We're told that the probability that Joshua takes 1 white sock and 1 black sock is 6 out of 11. Now let's take a look at the probability that Joshua takes 1 white sock and 1 black sock. We can highlight the 2 ways of doing this in different colours. To take 1 white sock and 1 black sock, well, he could take a white sock the first time round, and then after that he could take a black sock the second time round. Or he could take a black sock the first time round and take a white sock the second time round, because both of these represent taking 1 white sock and 1 black sock, since the order in which these are taken is not specified in the question. And so we can say that the probability that Joshua takes 1 white sock and 1 black sock is equal to the probability that he takes black and then white, or white and then black. So as a general rule, when we work with tree diagrams, we can say that we multiply the probabilities when we have and we add the probabilities when we have or, which will make a little bit more sense once we do this question. So the probability of choosing a black sock first and then a white sock, now since we have and, we said that we'll multiply, and so we'll do y over 5 plus y multiplied by 5 over 4 plus y. Now since the probability of finding 1 white and 1 black is the probability of finding black first and then white, or the probability of finding white first and then black, we're going to add the 2 probability combinations together. And then we need to do the probability of finding white first and then black, which will be equal to 5 over 5 plus y multiplied by y over 4 plus y. Now we're told that this is equal to 6 out of 11. Now that we have this expression, we can begin to simplify. And so looking at the first set of brackets, y over 5 plus y multiplied by 5 over 4 plus y, we're multiplying the numerator and the denominators together. We'll end up with 5y over 20 plus 9y plus y squared. And then doing the same to the second set of brackets, we'll end up with the same fraction, 5y over 20 plus 9y plus y squared. And again, this is all equal to 6 out of 11. Now we can add the fractions together. Since the 2 fractions have the same denominator, we just need to add the numerators. And so adding the 2 fractions together, we'll end up with 10y over 20 plus 9y plus y squared is equal to 6 out of 11. So when we cross multiply, we'll end up with 11 multiplied by 10y, that's 110y, is equal to 6 multiplied by 20 plus 9y plus y squared. Now we can simplify this by multiplying each term in the bracket by 6. And so 110y is equal to 120 plus 54y plus 6y squared. Now let's move the 110y over to the other side. So we can say that 0 equals 120 minus 56y plus 6y squared, which is the same thing as saying 6y squared minus 56y plus 120 is equal to 0. Now we need to show that 3y squared minus 28y plus 60 is equal to 0. So let's divide both sides by 2. And so we end up with 3y squared minus 28y plus 60 is equal to 0. And so we've now answered part A and successfully shown that 3y squared minus 28y plus 60 is equal to 0. Now in part B, we need to find the probability that Joshua takes 2 black socks. And so we have a copy of our tree diagram below. Now let's highlight the path that our tree diagram will take. To take 2 black socks, there's only one possibility, which will be to take a black sock the first time round and to take a black sock the second time round. So the probability of taking 2 black socks is the probability of taking a black sock and a black sock. So we said that when we have and, we multiply the probabilities. And so the probability of taking a black sock and then a black sock would be equal to y over 5 plus y multiplied by y minus 1 over 4 plus y. Now to find this probability, we need to know the value of y. In part A, we said that 3y squared minus 28y plus 60 is equal to 0. And so we can factorize this to solve for y. When we factorize this equation, we end up with y minus 6 and 3y minus 10 is equal to 0. And so rearranging, we can see that y is equal to 6 or y is equal to 10 over 3. Now we know that y needs to be a whole number, and so we can say that the only correct value is y is equal to 6. Now that we've found that y is equal to 6, we can simplify the equation for the probability of finding 2 black socks. So y over 5 plus y would be equal to 6 over 5 plus 6, and 5 plus 6 is equal to 11, multiplied by y minus 1, which is equal to 5, over 4 plus 6, which is equal to 10. And so 6 over 11 multiplied by 5 over 10 will get 30 over 110, which we can simplify into 3 out of 11. And so we've found that the probability that Joshua takes 2 black socks is equal to 3 out of 11, which we can write down in our answer box below. Now this question is worth 7 marks, so let's take a look at where these marks are allocated. We get the first mark for the expression that y over 5 plus y multiplied by 5 over 4 plus y, all added to 5 over 5 plus y multiplied by y over 4 plus y is equal to 6 out of 11. We get the second mark for simplifying this into 10y over 20 plus 9y plus y squared is equal to 6 out of 11. We get the third mark for cross multiplying and for ending up with 110y is equal to 120 plus 54y plus 6y squared. And finally, we get the fourth mark for rearranging and simplifying in order to get a final answer of 3y squared minus 28y plus 60 is equal to 0. Now part B is worth 3 marks, and the first mark in part B is for creating the expression that the probability of taking 2 black socks is equal to y over 5 plus y multiplied by y minus 1 over 4 plus y. The second mark is for factorising the equation in part A and for appropriately choosing the value that y is equal to 6. And the third mark is for substituting this value of y into our expression above and for ending up with the correct answer that the probability that Joshua takes 2 black socks is equal to 3 out of 11. And so we've now achieved the full 7 marks needed in this question. In this question, we're being asked to write the quadratic equation 2x squared plus 16x plus 35 in the form a multiplied by x plus b all squared plus c, where a, b and c are integers. And so to do this, we're being asked to complete the square. Let's take a look at how we'd approach this question. We have 2x squared plus 16x plus 35. Now we want to get rid of the 2 in front of the x squared, so we can factorise the 2 out, but looking at the a and b terms only. Let's write this down so that it makes a little bit more sense. We have 2, and then we have x squared plus 16x. But to factorise the 2 out, we'll have 2 multiplied by x squared plus 8x, which means when you expand these, you'll get 2x squared plus 16x, just like we have in our quadratic equation. And then we'll keep the plus 35 at the end. But now we want to get rid of the x squared, because we're asked to write this down in a form a multiplied by x plus b all squared plus c. So let's see how we can approach doing this. We'll keep the 2, and then x squared plus 8x can be written in a different way. Instead, to complete the square, where we have x squared plus 8x, we can write this in the form x plus 4 all squared minus 16. And let's explain what we just did. Now the 4 is here because we did 8 divided by 2. When we complete the square, we divide the coefficient of the x term by 2. So if we had, for example, x squared plus 6x, in our brackets would be x plus 3 all squared minus 9. Or if we had x squared minus 10x, we would have x minus 5 all squared minus 25. Now you may have realised that the minus 16 comes from 4 squared. And the reason we do this, well, we're looking at x squared plus 8x. And so let's imagine we have x plus 4 all squared. That's the same as x plus 4 multiplied by x plus 4, and expanding these brackets would give us x squared plus 8x plus 16. We're only looking for x squared plus 8x, and so we need to take away 16 because we have a plus 16 here, which we don't want. So now that we understand why we have x plus 4 all squared minus 16, we can continue with our question. And remember that we have the 2 in front of it because the 2 is multiplied by the whole thing. And then we have our plus 35 at the end again. Now looking at these brackets, we have 2 multiplied by x plus 4 all squared minus 16. So we can multiply 2 by each term. 2 multiplied by x plus 4 all squared is 2 multiplied by x plus 4 all squared. Now 2 multiplied by minus 16 is equal to minus 32. And then the plus 35 at the end. Now minus 32 plus 35 is equal to plus 3. And so we can write this down as 2x plus 4 squared plus 3. Now taking a look at what the question is asking for us, we're asked to write this down in the form a x plus b all squared plus c. We have an answer of 2x plus 4 all squared plus 3, which fits with the form given to us in the question. So we said that a is equal to 2, b is equal to 4, and c is equal to 3. And we can write down our answer below. Now in part B, we need to use our answer to part A to write down the coordinates of the turning point of the graph y equals 2x squared plus 16x plus 35. And because we completed the square, we can do this quite easily. We said that 2x squared plus 16x plus 35 is equal to 2 multiplied by x plus 4 all squared plus 3. Now to find the turning point, there's a certain trick that we can do. So if we have a quadratic in the form x plus a all squared plus b, our turning point will be minus a, b. Or if we had x minus c all squared minus d, our turning point would be c minus d. And you might be recognizing a pattern here. So the term inside the brackets, so in these examples would be plus a or minus c, they change sign. So the plus a becomes minus a, and the minus c becomes c. and the term outside of the brackets, b and minus d, well, their signs don't change at all. Now we can apply this logic to our question. Now the 2 in front of the brackets might seem a little confusing when it comes to finding the turning point, but when we find the turning point, we simply ignore anything that the brackets might be multiplied by. And so using the rules we just spoke about, the turning point would be equal to minus 4, 3, which we can write down in our answer box below. Now this question is worth 4 marks in total, so let's take a look at where these marks are allocated. In part A, we get the first mark for factorising the 2 out of our quadratic equation, and for getting 2 multiplied by x squared plus 8x plus 35. Now we get the second mark for writing x squared plus 8x as x plus 4 all squared minus 16, and remembering that we have the 2 at the front and plus 35 at the end. And now the third mark is for correctly simplifying and for getting our final answer of 2 multiplied by x plus 4 all squared plus 3. And in part B, we get the 1 mark for correctly identifying that the turning point of the graph is equal to minus 4, 3, based on our correct answer to part A. And so we've now achieved the full 4 marks needed in this question.